Question number 2 is a calculator question. And so, to the nearest hundredth, that kind of tells us that we're going to use a calculator. Solve the equation cos x minus 6 equals 4 cos x minus 4. So just like last time, we're going to need to combine our like terms and see if we can get cos by itself. Because anytime you're solving a trig equation, you're going to want to get whatever trig function you have all by itself on one side of your equation. So if I subtract cos x on both sides, I'm going to be left with 3 cos x on the right-hand side. If I add 4 to both sides, I'm going to get negative 2. And if I divide both sides by 3, now I'll get cos x equals negative 2 over 3. Now that value is not on our unit circle. And because it's not on our unit circle, we're going to need to use our calculator. Now we have to make sure we understand how the cast rule and reference angles work together for this. First of all, we're going to try to find the reference angle. The question's in radians, so we make sure that our calculator's in radians. And when finding a reference angle, we're going to do cos inverse of positive 2/3. A little review. Why do we always use positive values when finding a reference angle? Well, if cos is negative, you know that it's either going to be in quadrant 2 or quadrant 3. And if you draw a picture of an angle in quadrant 2 and go back to your nearest x-axis, your reference angle is right there. What do we know about this triangle? Well, we could label the adjacent over the hypotenuse because we know cos is 2/3. The adjacent side is 2, the hypotenuse is 3. And when you're thinking about an actual triangle with actual lengths, it makes sense why whenever we're finding the reference angle, we always use positive values. Now eventually, you won't be drawing these pictures, labeling your reference angle, right? This would be the one in quadrant 3. Eventually, you're not drawing those pictures because you're just going directly to your reference angle. You're going to your calculator. You're saying, I'm in radians. Good. Cos inverse of 2 divided by 3. My reference angle is 0.841. Now with your calculator, you might want to use the store button right now and store this value as x so that you can use it more than once. Because can you see when you try to find your angle in quadrant 2, you're going to need to do pi minus your reference angle. So since I stored it as x, I can go pi minus x, and I find out that my answer in quadrant 2 is 2.3. It says to the nearest hundredth, so that would be 2.30. Then in quadrant 3, I would have to go pi plus my reference angle. And since I've stored it as x, I can just go pi plus x. And in quadrant 3, I'll get 3.98. Now once again, you see that I got into a rhythm of finding my reference angle, and I solved once around the circle again. Sort of get into a habit of doing that. You've got your circle once around because you're checking your cast rule. That solved all my answers from 0 to 2 pi. A very important thing to do, though, is to look back and say, was that the domain that they asked for? No. The domain that they asked for was from negative pi over 2 to 3 pi over 2. So what does that mean? Well, that means I'm going to have positive angles from 0 to 3 pi over 2. And I'm going to have negative angles from 0 to negative pi over 2. I sort of always break it up and think about it as positive. Where are my positive angles? Because I can easily show that's looking for all angles up to here. And then I think about my negative angles and the fact that I've got negative pi over 2 to 0. Well, that means I would have angles from 0 to negative pi over 2. So I'll keep answers that are positive in quadrants 1, 2, and 3. And answers that are in quadrant 4, I'll have to write them as negative. But can you see that our answers were in quadrant 2 and quadrant 3? So we can actually go, this one is good, and this one is good. And even though they changed the domain on us, our answers stayed fine. Okay? The final exam would never do this. They would never change the domain so that if you didn't check the domain, you still got the right answers. If they're going to change the domain, they want to make sure that you recognize that, so you change it as well. But it just so happened in this case, we were able to get the right answers by solving from 0 to 2 pi. Okay, have we completely solved question A? Okay, to the nearest hundredth, solve the equation for from negative pi over 2 to 3 pi over 2. That's done. It says, then write the general solution. Okay, that we haven't done, so let's do the general solution. My general solution, it's x that I'm solving for, right? How do we do our general solution? We find all of our answers between 0 and 2 pi. We've done that already. That's 2.30 and 3.98. And then, once you've got all of your answers from 0 to 2 pi, the general solution just says add 2k pi, since we're in radians, to each one, where k is an integer. So the general solution part actually isn't very hard, okay? When we do our Chapter 6 test, the general solution is something new from Chapter 7, so it's not going to be on your Chapter 6 test. It's going to be on your quiz when we do our quiz from 7.1 and 7.2 and all of Chapter 6 combined. So the next quiz will have the general solution on it, but for your test, that will wait until your Chapter 7 test.
So technically the quiz has more content than the test will, technically?
Yes. Okay, so now reread question A again. Now we've solved everything for question A. So one of the things, I don't know if you noticed, but I read the question like 4 times in the process of solving this. That's a mathematical, I think that's unique to math, right? It's not like when you're doing a novel study in English and they say read chapter 4, how many of you decide to read it 4 times? Probably not, right? Sometimes you learn in certain subjects that it's okay just to read the first sentence and the last sentence of a paragraph, and you can sort of skip the rest, and that lets you read it faster. Okay, but math is not that way. Math, you have to read every detail like multiple times just to make sure that you've covered everything. So part B. To the nearest degree, so now we're working in degrees, solve the equation root 2 cosecant x equals negative 5. So first of all, we notice this has one of the reciprocal trig functions. Anytime you have a reciprocal trig functions, we can start it the same way as we solved all of our other trig functions. Can you get the function by itself? Yes, I can, by dividing both sides by root 2. And then, to recognize that the reciprocal of cosecant is sine, so if cosecant x equals negative 5 over root 2, then sine of x will equal negative root 2 over 5. Again, this is not on our pi plate. So go to our calculator. We'll find our reference angle. Remember, reference angle is always the inverse of the positive value. But now this question's in degrees, so we go to our calculator, go to our mode, and change to degrees, and you have to be able to switch back and forth often. Now that I'm in degrees, I can go sine inverse of, I'll use my fraction button, square root of 2, positive square root of 2 over 5. Again, remember when finding a reference angle, we use our positive values. 16.4, it does say round to the nearest degree, so our reference angle rounded would be 16 degrees. So then, what quadrants is sine negative in? Well, sine is negative in quadrants 3 and quadrant 4, according to the cast rule. So if my reference angle is 16 degrees, can you see that in quadrant 3 you would go 180 plus 16 to get 196 degrees? And in quadrant 4 you would go 360 minus 16 degrees for 344 degrees. Again, I first solved between 0 and 360 degrees. And now I cross my fingers and hope that was the domain they asked for. Oh. They asked for between negative 180 and 180. So if I draw a picture of what that means, well, my positive angles would go from 0 to 180, and my negative angles would look at negative 180 to 0, so that would be all of those angles. So I would keep answers that are positive if they were in quadrant 1 and quadrant 2, but I would have to have negative answers in quadrants 3 and quadrant 4. How did we do? Oh. Both of those are in quadrant 3 and quadrant 4. Maybe I should make those x's. There we go. And so my actual answers for x, what's going to be coterminal with 196 degrees? Negative 164 degrees. What's going to be coterminal with 344 degrees? Negative 16 degrees. How could you get those answers? Well, coterminal angles you can find by adding or subtracting 360 degrees. So one way you could find these answers is taking the answers you had and subtracting 360. Does that make sense? Okay. I personally still like to use my reference angles even with negative angles. So if I draw a picture here, right, a picture in quadrant 3 of my angle and label my reference angle here as 16 degrees, I would figure this angle out instead this way. I would say, oh, this is like 180 minus 16, and then I'll just put a negative sign in front of whatever that answer would be. And I would get negative 164 from that. And I find, especially in quadrant 4, right, here's my reference angle of 16 degrees. It's pretty obvious that that angle is negative 16. And that mental math seems a lot easier than having to take 344 and minus 360 from it. Okay, but both of those methods work. We have to find what was coterminal in the answers that they gave us. And then they probably asked for the general solution. Let's double check, read it again. Yes, then write the general solution. So for the general solution, and this is why I like that we have these answers, even though we put x's through them. I like that we solved between 0 and 360 degrees to begin with, because our general solution says find all your answers between 0 and 360 or 0 and 2 pi. So that's 196 and 344. Then add 360 degrees times k. Where k is an element of the integers. So there is our general solution. Again, your textbook, for a question like this, can you see that they might have, instead of the 196, that you could have written negative 164. And instead of 344, that you might have had negative 16 degrees. Because those are coterminal, and adding 360 to those ones would be the same answer. So sometimes students get a little nervous because they check the answer book and they have something that's different. But to understand that if the angle that's different is still coterminal with the angle you chose, it means the same thing. Okay, questions 6 and 7 for practice on this one.